Hello, good evening, everybody. Hope that you are all prepared for the extra class tonight. Have you done your mind map already? The big one, the big one that I photocopy for you. And I think I already told you if you want more, you can photocopy on your own. I think I already attached the soft copy, right? You print out on your own. Make sure that you print in A4 size, because the default size is the B3 size. The big one, the B we call it as a B3 or B5, whatever. Okay, so you have to what adjust in terms of the printing there to be the A4 size. So that's how you are going to get the correct scale. Okay. Okay. Now I heard rumors saying that your Sem 3 examination is going to be postponed again. To be honest, I don't know. I'm not sure about the validity of this news because I don't think they can afford to this postpone anymore, because if you keep on postponing until when they want the exam, so I don't know what to say. Okay, so let's wait for the official NPM news that published out from the NPM website. Okay, it may be hoax, you never know. Okay, so please do not come and ask me anymore whether it's a true news or not, because so far uh, I don't know. To be honest, I don't know. Okay. Okay. So without hesitation, shall we begin our lesson? So I hope that you have already prepared with your mind map. So for the beginning, we are going to do with the mind map. Okay. So we are going to go through all the this functioning group. We are going to study one by one for all the reactions inside here. So I hope that you all are prepared for this, and then we'll see what we can do in here. So are you guys ready? Okay, so without any hesitation, let's begin, shall we? Okay, so we are going to start off from the alkane. Okay, we are going to start from the alkane. Okay, so if you see carefully, alkane, we start from propane. Okay, so from propane, if you look at the arrow carefully, for propane to become a haloalkane, now what do you use in here? So, what you use? You use Cl2 under UV, okay? And what is the type of reactions in here? The type of reaction is a free radical substitution reaction. I just write abbreviation, and then later you put a remark saying that this is what type of reaction. So you have to know what type of reaction. And then also what I do not mention here is the mechanism. So if you feel that your paper is big enough for you to write the mechanism, go ahead, it's your paper. So if you want to squeeze everything inside that one paper, go ahead. It's your paper after all. So about the mechanism, I shall not discuss in this because we have already discussed during our last week the final revision lesson. If you still remember, so if you missed that, you can go back to the video that I've already shows you in here. Okay. Okay. So for alkene. And for alkane, I think that is the only reactions that you need to know. Okay, then when we go to alkene, propene. Okay, so propene, we start from this here. If you notice carefully. So from propene to become propane, so what do you use? Okay, you use hydrogen gas in nickel. Now, if you put nickel, you must put heating. Heating, no need to specify the temperature, just put triangle. Heating, reflux, everything, because reflux also require heating. So just put triangle. No need to memorize the temperature. Another alternative one in here is if you put platinum. So if you put platinum, it is room temperature pressure. Okay, you are able to change the unsaturated alkene to become a saturated alkane. Okay, so this is the reactions inside here. Okay, then going down to here. Okay, going down to here. Okay, from propene, you have 1 chloro and 2 chloropropane. Me stand for minor, Ma stand for major lah. Okay, so me and Ma in here follow the Markovnikov. So you go and check by yourself what does Markovnikov rule stated. Okay, so in here, Markovnikov rule stated that in the addition of the HX in the C double bond C, H is preferably to be added to carbon with more H. Okay. Okay, then what is the ingredient that you use in here? So in here you uses HCl. If you want, you can also add CH2Cl2, but actually in our lessons, HCl is far more than enough already. No need heating lah. In this case, no need heating, just simply hydrohalogenation. And then what is this type of reaction? This is the electrophilic addition reaction. Okay, electrophilic addition reactions. And the mechanisms. So try your best to know on your own on how to propose the mechanism for this reaction with HCl. Here. Okay, then the next reaction is how do we from alkene to become alcohol? So you must very specific that it must be H2O in gas. Okay, please bracket gas. Steam is a must. H2O steam. Okay, and then you use catalyst is dilute H2SO4. Enough already. Okay, then under reflux. So do write like this is far more than enough for you to get to alcohol already. About the H3PO4, how many degrees Celsius, how many atmosphere, no need to memorize, no need. Just focus on H2O steam, gas in dilute H2SO4 under reflux. Far more than enough already. Don't have to go and memorize unnecessary reagent. Okay, reagent. So, however, sometimes question can use that to ask you, so you must know by yourself that it is the hydration, hydrations in here. And of course, this hydration reaction is also another electrophilic addition reactions, and it also follows the Markovnikov rule also. Okay. Okay, then we circle up, we goes to here, propane 1,2-diol. So in propane 1,2-diol, what do you add in here to form propane 1,2-diol? You add KMnO4. It must strictly be KMnO4 in alkaline solution. Cannot be acidic. Must be alkaline, cold and dilute. Okay, cold and dilute KMnO4, so that you'll be able to form propane 1,2-diol. Okay, propane, not propan, typing error, propane 1,2-diol. Propane 1,2-diol. Then you form this one. And this is an oxidation reaction, and I hope that you note carefully is that the OH is at different carbon. If OH is at the same carbon and then it is further heated, you can eventually form a carbonyl compound. Okay, so this one you can see through in the alcohol chapter. What happens if you have a multi-halogen compound that has been hydrolyzed and heated? So you can go to that page to find out what will happen to them. It is a very, very small section where a lot of students will definitely tends to forget about that. Okay, so this is for propane 1,2-diol. Okay, so and then we have 1,2-dichloropropane, ClCl. So what do you use? You use Cl2 in CCl4. Okay, Cl2 in CCl4 or any organic solvent, CH2Cl2 also can. But usually, as I just ask students to memorize only one type, which is Cl2 in CCl4, far more than enough. And then the mechanism in here, the halogenation. Halogenations in here, the mechanism is very different from that of the HCl. So try your best to differentiate in between them. So of course, this is another electrophilic addition reaction. Then you must propose your own mechanism for how to draw. You can attach as a side notes on your own. Okay, and last but not least, how does propene become ethanoic acid, carbon dioxide, water? So this is what type of reaction? So this is a carbon cleavage where you cleave the C double bond C in here. Okay, so when you cleave the C double bond C, primary alcohol will become carbon dioxide and water. Secondary alcohol will become carboxylic acid. Primary alkene will become carbon dioxide and water. Secondary alkene will eventually become this carboxylic acid. Tertiary alkene will become a ketone. Okay, so this is done by using KMnO4/H plus. Acidified potassium manganate, hot concentrated. Okay, or sometimes they put just a triangle is okay already. Okay, hot means heating. Okay, so if you write hot, it's not wrong. If you write triangle, it's also not wrong. Same thing. Okay. Okay, so any questions that you want to ask for alkene and its reactions or not? And then, of course, it can undergo polymerization. Polymerization is not inside the mind map here. If you want, you can add on your own. That's why I said this is already your mind map. So you can go and purposely make up your own this mind map, say that this is polymerization, what will happen. And then the reaction with the, another one that I didn't put is the epoxidation, but that one for me is not extremely important because it's already out from the syllabus already. So this is your notes, so you have to play smart lah. Okay, so any questions for this alkene? Okay, so if no problem, then am I going too fast or not? If I'm going too fast, you can always stop me. Okay, so if no problem, then we goes to the haloalkane. Okay, so haloalkane, we start from the haloalkane to become alkene back. Haloalkane to become alkene back, what do you add? Still remember or not? I do prefer you all turn on your mic and say it out loudly, your answer, so that it is not, I'm not the only one who say out the reagent and condition. Up until this stage, when it comes to reagent condition, you cannot forget already. You must remember on every single reagent condition. If you can't do that, then you have to work extra hard during these last 2 weeks. Okay, so what do you add to form back alkene? You add ethanolic potassium hydroxide under reflux. Okay, this is a type of elimination reaction. Okay, this is a type of elimination reactions, where in the equations, you have to write out what is the eliminated product. So the eliminated product in here is the HCl, and elimination in here follows the Zef rule, Zef rule, whatever. Okay, that says that in the elimination of HX, H is preferably to be eliminated from a carbon with less total hydrogen. Okay, so I've already stated very clearly in the alkene chapter, so I hope that you will be able to look back at what is happening. Okay, then we goes to the left. Okay, so to form a butane nitrile, to form a, okay, we go to the right here, alcohol in here. Okay, so what do you add to form alcohol? Propan 1-ol and propan 2-ol, depend on what you add. So you add NaOH or KOH under reflux. Okay, so I see this one already. NaOH, very good. Okay, NaOH under reflux. Now, what is the type of reactions in here? So this is a nucleophilic substitution reaction. So it depends. If one choropropane, so this is a SN1 mechanism. Okay. Sorry, SN2 mechanism. Okay. If it is a tertiary alkane, then it is a SN1 mechanism. Okay. So this is, like I said, this is your own notes. You have to add out all the ideas on your own. Okay, then we goes to this one, how to become amine. Now amine, there are not many compounds that can form amine. One of them is from haloalkane. This one you must strictly remember. One of the methods to form an amine is by using haloalkane. Second is to use reduction of the amide. Third is the reduction of the nitrile. This is the only 3 way to synthesis amine. Okay, so what do you use in here to form the amine in here? So you use ethanolic concentrated ammonia. Okay, ethanolic concentrated ammonia under reflux. And this reactions is more viable for primary haloalkane. It's more viable for primary haloalkane. Secondary, tertiary, actually very hard to do already. Okay, so you must try your best to remember this. Okay, then the fourth reaction will go to this one. How do you form propyl magnesium chloride? So this is what reagent? We call it, this is a Grignard reagent. Okay, Grignard reagent. So when you forms a what do you add to form a Grignard reagent? Okay, you use magnesium in dry ether. Okay, magnesium in dry ether. Okay. Turn on your mic and answer. Okay, don't be shy. Last lesson already. You want to shy with me, also no more chances already. Okay. Okay, whatever. So magnesium in dry ether so that you form Grignard reagent. And then I'm going to focus only on this one where in this propyl magnesium chloride, what will happen? So this Grignard reagent, please bear in mind that it is the methods to increase the number of carbon by a lot, and the final product is mostly alcohol. So you can form primary alcohol, secondary alcohol, and tertiary alcohol. So what do you add to form a primary alcohol? So you must add, I use different color so that you can see clearly in here. So you must add methanol, HCHO. Okay, followed by acidic hydrolysis. Okay, now when you write the mechanism, when you propose reaction scheme, when you propose the reaction scheme, try to write out the intermediate product where or you have OMgCl, that one. Okay, intermediate product must be written OMgCl. You don't care whether got marks or not. You just write. As a student, you don't care whether there are marks or not. Your task is to propose as complete as you can. So, including the including this formation of the intermediate, you must also do that. Okay, okay. Then, so this is to form primary alcohol. Then if you want to form a secondary alcohol, you must use aldehyde other than methanol. So you use RCHO, then followed by acidic hydrolysis, H3O plus under reflux. Okay. Okay, now to avoid confusion, no matter acidic or hydrolysis, everything H3O plus. Don't care whether it's correct or not. Just put everything H3O plus so that you won't confuse. Okay, so everything H3O plus. Okay. Okay, and then you add this is aldehyde. Okay, and finally you add ketone. Ketone. So in here it is R naught C O R double naught. Okay, followed by acidic hydrolysis. Okay, followed by acidic hydrolysis. So this is the things that you have to know lah. Okay. Okay. So this is the how do you making use of the Grignard reagent to form primary, secondary, and also tertiary alcohol. Okay. Okay, and then we also have another way to form this carboxylic acid, but this is not really advisable because we have a better method, which is by using the nitrile. Nitrile is a better method, but still, it doesn't mean that it is impossible. So it is better for you to write, to know such thing. You add CO2 and H3O plus also to form the butanoic acid in here. Okay, so this is how you are going to synthesize the Grignard reagent, and by using Grignard reagent, you form different class of the alcohols in here. Okay. Okay. Last but not least is the formation of the nitrile. Okay. So this is add extra C lah. Okay. Add extra C, you use nitrile. Okay. So what is the reagent and condition that you use to add this nitrile? You use ethanolic what?
KCN.
Very good. Ethanolic KCN under reflux. Okay, ethanolic KCN under reflux. Okay. Now, to those who didn't turn on your mic, I hope that you are reciting together with me on your own because maybe you're probably still too shy with Mr. Chu. But I do hope that you already know the reagent and condition to fill in all of this. Please, you must know. Okay. Okay. So now, when you become nitrile, CN, there will be only two ending. Either you end up become an amine, or you end up become carboxylic acid. And if you notice carefully, from prop become wood. Okay, so you already add extra C inside here already. Okay, so how do you form the nitrile? So you use LiAlH4. The way of how we write the reducing agent is also very important. 1 LiAlH4 in dry ether. okay, followed by 2H3O plus. You write like this. This is the correct methods to write for reducing agent. Always remember to write like this, okay? And then as for butanoic acid, just simply H3O plus under reflux, acidic hydrolysis. And of course, you can also have alkaline hydrolysis. Okay, alkaline hydrolysis where you add the OH minus. So if you add OH minus under reflux, so you form CH3, CH2, CH2, COO minus. Okay, CH3, CH2, COO minus in here. Okay. So this is how you can do acidic and alkaline hydrolysis. So inside this mind map here, I didn't stress too much on the alkaline hydrolysis, but if you want, you can always add this on your own. As I told you, this is your notes already. So nak tambah ke, nak tolak ke, nak darab ke, nak bahagi ke, up to you already. Okay, so I hope that you can maximize the usage of this. Okay, so with that, that is for the haloalkane. 5 reactions only. Okay, I repeat, elimination by using ethanolic KOH to form alkene, hydrolysis by using sodium hydroxide under reflux to form alcohol, follow SN1, SN2 mechanism, primary alcohol SN2, tertiary alcohol SN1, and then you must also know the reason to explain also, please, this one I won't go through, okay, you have to study on your own, and then you have the reaction with to form amine, where you use ethanolic concentrated ammonia under reflux, and then you form Grignard reagent by using magnesium in dry ether. Finally, you use ethanolic KCN. Okay. So any questions for haloalkane? Am I going too fast? Hopefully no. Okay. So if no problem, immediately we move to alcohol. Okay. So alcohol, we start from the alcohol to become alkene first. Alcohol to become alkene. So alcohol to become alkene, what do you use? Okay, so this is a very important keyword. Excess concentrated H2SO4. Please write the word excess, and then under reflux. Excess concentrated H2SO4 under reflux. Excess concentrated H2SO4 under reflux. Okay. So this is the reagent. Then we go down here. How does alcohol form back haloalkane? You use what? You use either PCl5 or you use SOCl2. Okay. Now, Lucas reagent is only suitable for tertiary haloalkane only. That is the test for you to immediately see the white precipitate things. Lucas reagent. Okay. But when you convert alcohol to become haloalkane, especially chlorine, chloroalkane, so you use PCl5 or SOCl2 under reflux. Okay. Then, so alcohol becomes sodium propoxide. So this reaction is only the reaction with sodium only. Okay, sodium only. Okay. And then to form back this one, you add water, H2O, to form back the alcohol. Okay. Okay, by the way, I forgot to label excess concentrated H2SO4 is an elimination reaction. Elimination reactions, you must know. Okay, then we goes to the next one, the formation of the ester. So you use concentrated H2SO4 under reflux to form ester. Okay, so this one. Okay, and then how alcohol become propanoic acid? Either you use KMnO4 / H plus or K2Cl2O7 under H plus. Okay, reflux. Okay, both of them must be reflux. Okay. Okay, and last but not least, to become this one, carbonyl compound, you add this copper at 400 degrees Celsius. Or you use PCC. Okay, PCC also can. Okay. Okay, so far, is there any questions? Because I'm about to scroll up. In order for you to this one, I will print screen for you so that if you accidentally miss out any part, I'll be able to show you the correct one. Okay, so control oxidation, especially from primary alcohol to become aldehyde specifically, it must be a copper at 400 degrees Celsius or you use PCC in here. Okay. Okay, any questions? Okay, so hopefully no problem. Okay, so if no problem, now we are about to go up a little bit where we are going to go for carbonyl compound. Can I erase already? Okay, I've already print screen, so if you miss out, you can always refer back to this one. Okay, okay. So I'm going to go up here and then until here. Okay. Okay, so now we goes to the carbonyl compound. So for carbonyl compound, there are only 5 reactions. Okay, so let's start from propanol propanone to become alcohol back. So propanol propanone to become alcohol back. So you have to use reducing agent. So you use LiAlH4 in dry ether, followed by number 2 H3O plus. And the reflux in here. Okay, reflux is not compulsory. Even if you don't put reflux, also can. The keyword is LiAlH4 in dry ether followed by H3O plus. So this is the way of how you are going to write the reducing agent. Okay. Okay, so alcohol oxidized to become carbonyl, carbonyl reduced back to become alcohol, and carbonyl can only this aldehyde can further undergoes oxidation. And this one, can you help me to correct? Is CHO, not COH. Sorry, CHO, not COH. Okay, CHO. So you use oxidizing agents such as KMnO4, okay, or K2Cl2O7 under reflux, so that you'll be able to form back your propanols in here. Okay, then the third one, this is a very, very important reaction where in here you form this cyanohydrin. Cyano stand for Cn, hydrin stand for OH, and this carbon is an alpha carbon. Still remember alpha carbon is what? Alpha carbon is the carbon that holds 2 functioning group. Okay, alpha carbon is carbon that holds 2 functioning group. Okay, okay. So what is the reagent condition to form these alpha carbons in here? No news? Okay, so it is HCN in NaCN. Okay, so as usual, the moment that you add Cn, it is addition of the extra carbon. Okay, you have extra carbons inside there. Okay, so this is how you are going to propose for this one. Okay, then once you become the Cn, then there will only be 2 ending. So if you use up acidic hydrolysis, okay, so you become carboxylic acid. Now, this carboxylic acid, always try your best to remember. When you see a functioning group with OH, CH, and then the COH, so you have to automatically know by yourself OH and COH at the same carbon, okay, it must be the only culprit that do this is HCN in NaCN. So by hook or by crook, you have to convert them to become carbonyl compound. Okay, you have to convert them to become carbonyl compound. Okay, and then if you want to form CH2 NH2, so of course you use reducing agent. Okay, followed by reducing agent. Okay. Okay, by the way, what is this type of reaction? This is a nucleophilic addition reaction. Nucleophilic addition reaction. Okay, so try your best to remember the type of reaction and the mechanism. Also try to look out for the mechanism for this reaction, please. Okay. Okay, so this is for reaction with the CN. And then this one, this is a condensation reaction. Condensation reaction where you have to eliminate small molecule. Side product is a must where you eliminate H2O out from here. So what is the reagent condition? So you must know how to draw 2,4-dinitrophenylhydrazine. Okay, so 2,4-dinitro means that you have NO2 at the 2 and 4. And then you have a NH, single bond NH2. So this is 2,4-dinitrophenylhydrazine. So try your best to remember. And what will you observe? You observe orange precipitate. I use orange color lah, since this one, orange precipitate. Okay, orange precipitate. This one, purple color decolorize, KMnO4. You use K2Cl2O7, then is orange become green. Okay. Okay, then as for this one, aldehyde, you can have two tests. You use Fehling solution. So Fehling solution is Cu2 plus. Okay, Cu2 plus in the OH minus under reflux. Okay, so you form a brick red precipitate. Okay, you form a brick red precipitate. And then for this one, for the silver, so it is a silver lah. In here, silver mirror lah. So for silver mirror, the reagent that you use in here, please write down the complex AgNH3 plus in alkaline solution. All of these tests must use alkaline solution. Even for this one, this is only works for propanone only. Okay, so it is the iodoform test. So for iodoform test, it is I2 in the OH minus under reflux. Okay, so you must have the presence of the this COCH3 lah. Okay, same goes with this one, propan 2O. If you can match up later, you might also want to write on this one. Okay, propan 2O to become this iodoform in here. Okay. Okay, so this is for this one. Okay, so this is for carbonyl compound. Okay. Okay, then the next one will be, okay, I'm going to clear my drawing already. I haven't print screen, sorry, before I forget. Wait, I forgot the print screen. Okay. Okay, so this is it. We move back to this one. Okay. So now I'm going to clear already. Okay, then we are going down already to the carboxylic acid. Okay. Okay, so for carboxylic acid, I'm going to zoom out a little bit. Okay, so for carboxylic acid, zoom out. Okay, so this carboxylic acid, okay, so we start from the sodium propoxide. So for the sodium propoxide in here, you have a few. You can use Na, or you can use NaOH, or you can use Na2CO3 to form the salt. And then this one, to form back this one, you add the acidic back, acidic solution back. Okay. Okay, then we goes to how carboxylic acid become alcohol back. Carboxylic acid become alcohol back is LiAlH4 in dry ether followed by H3O plus as usual. LiLH4 in dry ether followed by H3O plus. Okay. Okay. Then propanoic acid to become propanoyl chloride is you use as long as OH to become Cl is definitely PCl5 or SOCl2 lah. Under reflux. Okay. Okay. And then carboxylic acid to become amide. So this one you use concentrated ammonia under reflux. Okay. Concentrated ammonia under reflux. And then carboxylic acid to become ester. So as we already deduced just now, we use concentrated H2SO4. Okay, now we go to carboxylic acid derivative. So for carboxylic acid derivative, so propanoyl chloride to become propanoic acid, simply you add up water only lah, H2O. Propanoic acid to become propanoyl chloride to become propanamide, you just simply add up NH3 under reflux. Okay, so this is the and then last but not least, if you want to become different classes of the amide in here, so you just simply add acyl chloride react with primary amine to form secondary amide. Okay, secondary amide. Okay. Okay, so this is for carbonyl this acyl chloride. Okay, and then for this ester you only have two reactions in here. So what are the two reactions involving ester? So the two reactions involving ester are, number one, you use H3O plus acidic hydrolysis, you form back the alcohol to become carboxylic acid, and this one. And then there is one more that I hope that you draw the arrow on your own. You form this one, primary alcohol. So you use a reducing agent, okay, LiAlH4 followed by H3O plus in here, okay, followed by H3O plus. So you form the primary alcohol, okay. Okay, so this is the two reactions involving ester. And then last but not least, it is the amide. Amide to form back alcohol is acidic hydrolysis, of course, acidic hydrolysis under reflux. Amide to form amine. This one, propan to form ethyl, this is out of syllabus. Actually, it's bromine in the NaOH, but this is Hofmann degradation, we call it, but out of syllabus already. So don't bother about it. And then propan amide to become propyl nitrile, so you use P2O5. But this one also out of syllabus and seldom asked. Don't worry about this. And then for both of them, if you want to become propylamine, so you use LiAlH4 in dry ether, followed by H3O plus. Okay, followed by H3O plus. Okay. Okay, so this is all for the carboxylic acid derivative. Okay, because of the time constraint, sorry, I'm a little rushed. Okay, the last but not least is amine. Amine only have three reactions. Amine react with HCl to form salt. Okay, and when you add back NaOH, you form back the amine back. Okay. So this is the reverse reaction. And then number two, if you want to form NH2 to become OH, okay, so what do you add? You add NaNO2 in HCl 0 to 5 degree Celsius. Okay, and then this one, as we already deduced just now, if you add primary amine to acyl chloride, you are able to form different class of the amide in here. Okay. Okay, so with that, I guess that is all for the mind map for this alkane. Okay, so we are going to continue back later. I just go very fast on the aromatic compound, and then that is all for our extra class. I also don't want to take up too much of your time also, because you might want to do your own revisions after this. Of course, if you have any question, you can always private message me no problem. So I'm going to share the link right after this, and then 2 minutes, then immediately we start our lesson. Okay or not? Okay, very fast one. Okay. Okay, so with that, that is for the first session. So I'm going to meet you 5 minutes later for the second session, okay, for the aromatic compounds mind maps, okay. Okay, so see you guys later.